There is another way altogether that you could have solved this problem. It comes from the idea which we explored when considering the Lambert's chart. The difference between a straight line and a rhumb line is always half chart convergence. Considering the route from A to B, the rhumb line will be the parallel of latitude. So what will the initial track angle be? Parallels of latitude can only have two tracks. They either go due east or due west. The initial rhumb line track angle from A to B must be 090. We know that the chart convergence is the same as the change of longitude. It's 120 degrees. Therefore, the difference between the rhumb line and the straight line must be half that. It's 60 degrees. So measuring 60 degrees anti-clockwise from 090, the initial straight line track angle is 030, the same result as when we solved it using triangles. Finally, before leaving this example, let's look at the initial track angle from B to A using this half-chart convergence method. Here is the rhumb line track. What is its track angle? It's obviously 270 degrees true because it's a parallel of latitude going westwards. Again, half-chart convergence is 60 degrees. So again, measuring 60 degrees clockwise from 270, the initial straight line track angle is 330, the same result as before. Let's look at another question now. Here's example 2. At what longitude does the straight line track from A at 70 north, 40 west to B at 70 north, 80 east on a polar stereographic chart reach its highest latitude? The four option answers are A, 40 west, B, 30 west, C, 20 east, D, 40 east. As before, draw a diagram. Again, the latitudes at A and B are the same, so you can draw a parallel of latitude. And again, because we're in the northern hemisphere, draw the Greenwich meridian coming in from the 6 o'clock position. Now put A at 40 west and the line joining it to the pole, and B at 80 east with its meridian. Now going back to the question, where will the straight line track from A to B reach its highest latitude? The highest latitude occurs when the co-latitude distance is shortest. This must occur when the track is directly abeam the pole. You can see that the distance here at the right angle is shorter than here or here. The two latitudes are the same, so we are dealing with an isosceles triangle again. Therefore, the line which is perpendicular to the base must be the bisector of the apex angle. If the angle from 40 west to 80 east is 120 degrees, then each half of the bisected angle at the apex must be 60 degrees. So you can either count 60 degrees eastwards from 40 west, or 60 degrees westwards from 80 east. But either way, you come up with the same answer. The highest latitude is at the mid-meridian, which is at 20 east. This idea that a track is at its highest latitude when it is perpendicular to the meridian can be useful in solving track angle problems. We have encountered a similar idea before right at the start of the course when we were studying vertices. The vertex is the point on the great circle when it is closest to the pole, and the track is always 090 or 270. This idea is sometimes used by examiners. Take this question. On a polar stereographic chart, a line is drawn from position A at 70 north, 102 west, to B at 80 north, 006 east. The point of highest latitude along this line occurs at longitude 35 west. What is the initial straight line track angle from A to B, measured at A? As usual, you are given 4 option answers, which are A, 049 degrees true, B, 077 degrees true, C, 229 degrees true, D, 023 degrees true. As always, draw yourself a sketch. With just the departure and destination points and the meridians, it should look like this. If you couldn't think of any other way, you could do it by scale drawing. This is the angle that they are looking for. If you draw the angles accurately, making sure that the radius to 70 degrees is twice as long as that at 80 degrees. You will see that, of the options given, 023 is the only possible answer. However, again, this is not what the examiner is expecting. He has given you the information that the point of highest latitude occurs at longitude 35 west. We should use this. Let's put the information into the diagram. Now let's consider this smaller triangle. Angle C is a right angle. The examiner has effectively told us this. Angle B is bounded by longitudes 35 west and 102 west. So the change of longitude is 67 degrees. As this is a polar stereographic chart, angle B is therefore 67 degrees as well. The internal angles of any plane triangle must add up to 180 degrees. There are 90 here. That leaves the other 90 to be split between A and B. 90 minus 67 is 23. So the angle at A is 23 degrees. And, as before, the line from A to the North Pole is a meridian. So measuring clockwise, we get a track angle of 023 degrees true. We now summarize this lesson. Many exam questions are based on the idea that, for the polar stereographic projection, the track angle change between any 2 points is exactly equal to their change in longitude, whatever their latitude. We showed that this was true in practice with an example in the Northern Hemisphere and with another one in the Southern Hemisphere. We then explored the angles around a straight line track where the start and finish latitude were the same. We were able to calculate the initial track angle by using the idea of adding the angles in an isosceles triangle, or alternatively, by using the concept that the angle between the rhumb line and the straight line is half the chart convergence. We then established that the highest latitude of a straight line track occurs when the track cuts its meridian at right angles. Finally, we used this principle of the right angle occurring at the highest latitude to solve a problem where the start and finish latitudes were not the same.